So you're welcome to Altium Designer. I think everybody has installed it. Yeah. So Altium Designer is a software for designing PCBs. It can also be used for running simulations, just like multisim, but I don't like using it for that purpose because it's very advanced and it takes time to build those models. It's very good for PCB design, the best probably. Yeah. So today we just about 1.5 hours. We just quickly run through how to do everything. So first, I'll go to here. You need to understand some basic things about PCB. So what is PCB? What is PCB? So what I'm saying is, basically, you have to get to know what PCBs are. So what is PCB? What is a PCB? Just Google that and can go to PCB basics. They tell you so many things you need to know about PCB. So you can go to learn https learn sparkfan.com tutorials PCB or and it tell you about PCBs. Alright. Copper layer, solder mask, silk screen, ring, DRC, so many things. Mostly all the terminology you need to understand before you use any software. So I hope after you are out of here, you're going to have a look at that. So let's just quickly move on to this. Now in PCB design, basically we work with schematics, which I know you know what a schematics is. So a schematics is something like this. Let me pick a simple one. So it's just a connection of electrical symbols or components. Okay, so how it should be connected electrically is what a schematic is. All right. So let's first we want to design a simple PIR sensor sensing board. Okay. Now the idea is we already have a library of components. Understand me clearly, we already have a library of components. That means that we have already pre-built the components individually. So they are already there. So all that we are going to do is just like how we did in multisim. We just drag and drop and connect. Okay. Yes, but normally you wouldn't have all the components pre-built for you. You have to do it yourself. So I'm going to show you as well how to do it. But just to give you an overview of how the entire process is, I'm just going to do a simple board, and after we are done, we learn how to create our own symbols and components. All right. So to create a new, we have to create a new project. All right. So go to File, New, Project. Okay. Let's pick default. Just don't worry about any of this. You are never going to use them. So just go pick default project name. Say my first PCB design. All right. Let's look at what's here. Nothing really. So just create it. So see, it has been created here. So it's a project. We can find where it is by going to right clicking and going to explore. Right. It's been added to documents, Altium, projects, Negdet Innovia, workspace. This is projects I've been working on, so I've grouped them. That's why it's here. So you can find them at my first PCB. Where should that be? Okay, so to find it again, just go to explore. You can see it here, workspace, my projects, my first PCB. Okay, so you see a projects, my first PCB, and then the file. Good. So to just know where it is, just right click and go to explore, and you can find it. It opens for you. So let me close this, or let me just keep it there. I need to add a schematic document or a schematic file. So I'll right click, I'll come here, right click on it, add new to project, schematic. So you see a new schematic file has been added. Then I need to now add a new Now just hold it there. Okay, now I'm ready to now add components. All right, so I need a resistor, I need a capacitor, I need a PR sensor, I need a connector. What am I talking about? If you look at this, yeah, if you look at this, okay, this is what we are trying to build. Okay, this is a PR sensor, this is the connector. We have some resistors down here, we have some AND gates, and then we have some capacitors here. Okay, so we need to add all these components. That's what I'm trying to talk about. So what I'll go to do is go to components. In yours, it's not components. I think it's parts or something like that. But it has a similar. No, in yours it's library. I'm using the 2019 version. That's why it's components. So you go to components. Okay, and then you can search for the part. But before then, I will want you to understand certain things. These are something like palettes. If you bring it, see, it keeps on changing. It keeps on changing. Let me just close a few of them. Components. I'll close it. I've already set it up. That's how you see it that way. But as a beginner, you may not have a lot of these there. And let me just keep it here. Data. Close the data. Right. So the first thing when you are setting up your Altium Designer is to go to panels here. Panels, and you can find all the panels here. So if I go to projects, see the projects I can add it here if I want. Okay, some prefer to work from here. I don't like to work from here. So I rather prefer it to be here. Okay. Now to add the library, I'll go to components. In yours it's going to be library, but in mine is named components. Okay, all right. So and then I can add a few other things which may be important to me. Fast search, yeah. All right. So I'll go to components. All right. I'll enter first. If I know the part name PIR, you see. Do you get what I mean? The footprint is has a character PIR. That's why I use the search. If it marks a number of components, it will have listed all of them. Okay, so this is so I'll just right click on it, place. Okay, so you see it's now here, and I can place it. Okay, now I can edit its P. We will talk about it. Is a name, the symbol name in the schematic. This is actually the actual name of the part, EKMC. We can find it if we go online. Okay, we can find the actual part if we go online. You can see that. Can you see it? So that's the actual component name. But for example, if you are using resistors, you can't put the name of the resistor, you just put R. If it's a capacitor, put C. So if we're PR sensor, I choose to name it P. So P what? Maybe there are going to be a number of PR sensors, maybe P1. Okay, good. Now, can you see that as I'm moving, it's moving as like step by step. It's because I've set a grid. I don't like it that way. I want it to move smoothly. So what I'll do is I'll go to View, Grid, Set Snap Grid. You see, it's set to 5 millimeters. Good. But sometimes the dimension, the unit of measurement will not be millimeters. It will rather be mils, milli-inch. All right. So I can rather toggle the units. Okay, and you can see that if I toggle the units, it's now set to 10 mils. We don't work with mils, we work with millimeters. So I just showed you how to toggle it. Now let me set the grid back to say 0.1. Okay, and now I see that it's moving smoothly. It's moving very, very smoothly. And you can see this is 0.1. All right, good. Now I've added this part. Okay, let me add a connector to it. Now, really, I don't have time to put all the connectors in my head. So what I'll do is I'll just go back. I created all the parts. Okay, so this connector, this is the name of the connector. Okay, so I'll just go and then search for it. All right, search. See, when I placed it there, you get what I mean?
Yes.
Good. And then there's another way to also find files or parts. You can go to file, depending on your version. You can go to here and then file based library search. Okay, do you get what I mean? So assuming I was looking for capacitors, all right, I can add capacitance. So if I press C spells it out for me. I press the tab key and it goes to equals to. Now, what values of capacitance do I need? I need just 0.1 microfarad capacitors. All right, I'll click on search and it lists a number of them for me. You can see, all right, this is another one. These are all parts I've created. All right, so we learn how to do that. So I'll just select any, all right, and then place it. I need 5 of them. How do I know? I know. So right now now to access the properties, okay, instead of clicking to place it, I can rather press the tab key. See, if I press the tab key, the properties come on. All right, I can do C1. Okay, enter. Can you see that it's now C1, C2, C3, C4, C5? Okay, that's how it is. All right. So now what I want to do is just arrange this. These are like filtering capacitors, or just like, remember something like that in the microcontroller, filtering capacitors. So now to connect it, okay, these are the pins of the capacitor. Okay, to connect it, I can go here to this place wire. We are in the schematic, we are not routing, so I'll go to place wire, or I can use, it's the same symbol around here, place wire. All right, I'll click on this, place that. Okay, click on that, place that, and the same way, click on that, place that, click on that, place that, and then connect the bottom together. This to that, this to that, this to that. Good. Now remember, what I've done is just really just I can hide these names. I don't need them. I can hide them. So I can double click on it and click on this. You see, I can hide it. I don't need them. You can hide all of them. Can select or go to properties. Okay, now there's a way to do that. Don't worry, there's a way to do that. There's no access about that. And just hide this the same way. Just keep hiding. I don't need the names, I just need the values. Okay, so you can arrange them the way you want if you're happy with it that way. Okay, right. Now remember, all that is happening is I've just really connected the capacitors to, I've not given it any voltage. All right, so I can place a voltage here. All right, or this is ground. I can place a voltage port here. So see, voltage power port, VCC. I can name it +5 volts, okay, and I put it there. All right, and I can add ground to it. Okay, so now it's connected to some voltage source. Now remember that the the PIR also needs a voltage and a ground. Okay, it's the same voltage. All right, so what I will do is just connect this to that. Okay, you see that, and I want to also connect this to ground. It's the same ground here, is the same ground there. To copy it, I could have just come here and then, now You see, when I click on it, if I want to rotate, I press the space and rotate. Okay, if I want to flip it, I press on the X and it flips. Okay, so I just bring it here. If I bring it, you can see that it wants to connect you, so you just click it. I can drag it. Yes, it's looking nice now. All right, now what we are not done yet. Okay, so I'll hold on a second. Now what I still have to add is I want to add this connector. All right, it's a header. It's a header connector. This is a part name. Okay, so I'll go there. I don't want to be searching, that's why I'm just going there to copy. All right, it's not, yeah, good, no problem. It's because I did a first search, so I'll just go back to this. See, it comes. I can double click on it and it still comes around. Okay, right. So this one, I want to connect the first pin to the class 5. So I press on Control key and then drag it. No, sorry. Press on the Shift key and drag, and it creates a copy. I can rotate it, right, or flip it. See, I want to connect the third pin to ground. Press on the Shift key, drag. Okay, now I want to connect the output of this PR sensor to this pin. Alright, so all I have to do is do something like this. Okay, now these are pins I don't like to connect anything to, or maybe let me just connect an LED to it. So I'll just come here, search on LED. See, I've already created some around here. Can you see it? I've already created some around here. I want to show you the model. So there's the LED. This is how it looks like. Okay, and this is how this one looks like. See, I don't like this one. I created all, so I just like this one, but I need a resistor. So L, I've named it L because it's light. Okay, so go back again. You need a mouse to do this, so I could just say L1. Okay, now I need a resistor. I need like a 240 ohm resistor. So I say 240, but 240 is so like vague to give me a whole list of items I don't like. I don't even know what it is, whether it's a resistor or something. Okay, but this is a resistor. This resistance is 324. I don't like it. Okay, so I will not use this. I'd rather go to search, file based library search. I'll go to, instead of resistance, okay, then I'll click on this and I'll search through and pick 240 or something which is close by. 220, 240. All right, I click on search and it gives me all the 240 ohm resistors I have created. Okay, I had to create all of these one by one. Okay, so I like this, so I just click on right and then add it over here. Now I want to just set it to R1. There is a way to automate it though. Set it to R1. Right, that's all I need. And then let me just add this, sorry. This and that to that. Okay, now remember that. So the microcontroller will control the LED through this. Alright, and it needs to go to ground.
Yes.
You get that?
Yes.
Okay. So that's, and this last pin, I don't need it. So in order to not generate any errors, I will just put this mark there. I was When it compiles, it will give an error. Then I'll save. I'll save it as my first PCB. Alright, you can use any name. My first PCB. See, it saves as that. Alright, good. Now we are complete. So what we have to do is let's compile to see if there are any problems. So I'll right click on it and say compile. Compile. If you want to see the output or the messages, you go to messages. Okay, it will tell you if there were an error, the message will come itself that there's an error. You have to go and solve it. Right. Undesignated part P. Part P. Can you see that? We don't whether it's P, is it P1, P2, P3, we don't know. Let's leave it like that. Okay, we are going to solve it automatically. So I'll go to choose annotation, force annotate all schematics, proceed. Yes. Can you see that it's changing from P to P2?
Yes.
Good. Alright, so let me compile again and let's go to the messages. If there were some critical message, this will pop out itself.
Okay.
Let's do an example. Let's just do an example. Let me just remove this from there. Okay, and compile. That's still not an issue. Let me do this. Why is it not giving me any issues? Messages. Still compiling. Anyway, don't worry. Normally, if there are issues, it will compile and give errors. Let me just. Alright, so now we are ready to go into the PCB design. Right now, we're just doing wiring. Okay. Now, you see, I told you that to change the grid, you know where to go. Grid, set snap grid. Alright, to toggle the units. Alright. Now, I want to now go to the PCB design, so I'll add a new PCB document. Add new to project PCB document. Okay, so you see it creates it. I'll save it with the same name, right? Just add my, alright, and then remove the extension and it will name it .pcb. So you see my PCB schematic, my first PCB design .pcb doc. Alright, so now I'm here. I'm now here, okay? Good. So let me just close this. Alright, now I'll compile again. And then I want to now transfer these files to the PCB where I can begin routing. So I'll go to design, updates, PCB document. Okay, it shows you all the things it's going to do. If you are happy, you just click on validate changes, execute changes, and then close. So it has transferred everything here. Usually this thing, okay, delete it. This thing, just click on it and delete it. Okay, can you see that it has come?
Like I said, please, after deleting it, it will come itself like this.
If you didn't delete, it will look yellow.
Okay.
Usually just delete it.
Okay.
Alright, now we have to now set the shape. Look at this. You see, can you see the board shape? Can you see it? It's very nice, right?
Yes.
You need to set the shape to the way you want it. Okay, so I don't like this, is too big for just a few parts. Alright, so what I want to do is to shape the board. So I'll go to view, 2D layout mode. See, it's already in 2D layout mode. I'll go to board planning mode. So you see, it's now in board planning mode. Alright, I want to set the origin. Set it to here. Okay, here to the just the first vectors of the board. I'm now ready to begin making the board look nice. All right. Now what I want to do is to make life easy. I see the it's like the divisions are very small. Okay, it will make it very difficult if you want to plan it. So what I want to do is to set the grid to something bigger. Now you see it's in 5 mils. I don't like mils because we don't work with mils. So I'll toggle the units. It should be in millimeters now. I'll go to grid. Set it's now in millimeters. I'll set it to 5 millimeters. Can you see that it has become bigger now?
Yes.
Bigger. Okay, good. Now we just want a 25 by 25 or 30 by 25 board. So still remember we are still in board planning mode. I'll go to design, redefine board shape. If that's what you want, you can edit it. Okay, I can do this. You can pick any point here. See, if I press on the yes, escape for the moment. Redefine board shape. I'll get here. See, as I move, you see, it's 0 0. Check this. Okay, you see, it's 0 0.
Yes.
I've moved 5 millimeters in the Y, 10 mils in there. So I just want to move 50, 20, 30 in the Y. I'll click. Move about 50. I'll click. Move the same. I'll click. And you see, I'll get back and then right click, and that's it. Do you get what I mean?
Yes.
I can even round the corners. I can round it. With that, I'll go to modify board shape. Okay, I want to round the corners. I can click here. Okay, cut it. But if you press on the shift and space bar, see, I'm getting different effects. Can you see it?
Yes.
As I press on the shift space bar, I'm getting different effects. So I want this. Okay, but I want it to flip over to that end. So I'll press the space bar. You get that? That's the new mode I'm in now. I'll go to modify board shape again. Pick this. Okay, now that's the mode I'm in now. Okay. Modify board shape. Okay. Let me go to a different mode. You see, I'm now in a different mode. It's not orthogonal again.
Yes.
You see, this one is in like. Can you see what it's doing?
Yes.
You see that? You see, it's having some curve.
Yeah.
It's now box, square, curve, any. Good. So this is what I want. So I just right. Looks like I've made a mistake, right? No problem with that. So let me just go back. Okay, and then go back to modify board shape. Right. This is what I want. Where I want to be. I'll put it here. And then click. Go back to modify board shape. Right. Because I'm already in that mode. And modify board shape. Good. Now it's looking nice. Okay, the board is looking really nice. So I'll now go back to 2D layout mode and I'll save. Now if I press on the key 3, number 3, it brings it to 3D view. So I can see how the board looks like. Okay, it still looks quite big though. No problem. I'll just drag this and bring it here. Now remember, I set it to 5 millimeters, the grid. So it will make life hard. I won't get to certain points. So I'll just set the grid to maybe 1 is fine. And it's smoother now. Okay, I can rotate it if I want. See, it's rotating. Good. And I can just drag this and place it anywhere I want. But you need to plan your board carefully. Okay. Now there's something called keep out area. Let me keep out area. Let's talk about that. After you have routed it, you see during manufacturing, you don't want them they this one is not the only board. If you send it to them, this is not the only board they'll do. They will have to add every they have other customers. They will add all their boards together and do it. And afterwards they will cut it. They will cut your board out for you. You don't want a situation where as they are cutting, they'll go and cut your trace or a circuit line. Okay. So there's something called a keep out area. You do it to tell them that okay, all your circuits, the wirings are within this area. So any area from here is safe. Okay, read on it and you know what a keep out area is. So what will happen is I'll just click on now. You see now, good. We have the PCB has several layers. The PCB can have several layers. We have the top layer. Okay, I've not introduced that. So with that, let me just come open this. It's a full layer PCB. Okay, we have the top layer. You see, where we put our components, top, and where we do our routing. We can also have a bottom layer. Bottom is usually called solder side, or we can edit the name. Right, but the point is we have a top layer, top side like this. See a top side like this, the top, and then we have the bottom. Okay, and we can even have internal layers. If you look at it carefully, you can see that we have another layer like this and that. Can you see it? Now I am in the 3D view because I clicked on number 3. So you see this is another layer, this is another layer. Okay, so let me go back. So I'm now in the top layer. To see the bottom layer, you click on solder side and you can see the bottom layer. To see the inner layers, we have a ground plane. See, this is how the inner layer looks like. And then we have a power plane. Okay, so that is layers. We have so many, a PCB can have so many layers. Now in this, we are using only 2 layers, top and bottom layer. Okay, we are just using only 2 layers. All right. To change the number of layers, you can go to layer stack manager. I don't want to go there right now. Just let's lay the foundation. Okay, you can change the number of layers here and add so many other things, but let's not go there now. Okay, so you can see that in my PCB, this PCB, we have top solder, top overlay. Let's talk about it. The top overlay is, see, when you watch any PCB, you can see something like R1, R2, and things like that. Okay, J6, D2, R5, R4. Okay, it's not really on where there is it has its own layer. All right, they print it and like something like attach it to this. Okay, so it's called the top overlay. Top overlay. Then we have the solder, top solder. That is it's a coating. It's a coating they put over the line so that it will cover it. Why? And yes, maybe if you are soldering, you see that you may unintentionally mess with the lines. So it's a coating they put over it. And then we have top layer. This top layer is where the signal lines are. Okay. And then we have dielectric. It's a separation. It's a separation between the layers so that one layer doesn't contact the other, or there will be short circuits. And then we have the bottom layer. Bottom layer is where the solder, the lines, the traces are for the bottom side. The top layer is where the traces are for the top side. Okay, if you look at this. So I told you that we have the top overlay. That's a layer where you can add text and things like ground plane, L1, L2. After that, we have something called solder resist. It's it's very strong. It won't even bend if you are soldering. It's so strong. It's so thermally strong. Okay, it's poured some glossy, some it's poured over the PCB so that it covers these lines. These lines. Okay, and then we have another layer where there are these lines there. Okay, so this is the top and this is the bottom. So the bottom has also got a bottom overlay where the text is the solder resist to cover it and the layer for the lines, right? So I've explained it. So we have that electric bottom layer where the actual lines are, and the bottom solder resist. That's where we place the coating over it, and the bottom overlay where we add our text. So that should be enough explanation. Okay, so now I can add the components to the top or bottom, but usually for these are called through hole parts. Through hole because you have to dig a hole and put them inside. Okay, and these are called SMDs. SMDs, surface mounted devices. Okay, so this is a through hole because it has to go through a hole. This is an SMD. Usually, through holes are always on the top layer every time. SMDs can be on either the top or bottom layer. So let me just put here. You see, to rotate it, I drag as I'm dragging. I can press the space bar and it's rotating. Okay, I can drag it to any point I want. Okay, and let me just arrange this. Put them some on the top, and then let me put some on the bottom layer. How do I put it on the bottom layer? I'll highlight it. Go to properties. Okay, and then I'll select the layer, bottom layer. It's now on the bottom layer. The bottom layer is usually blue. You see the color is red. Bottom layer is blue. So blue means it's on the bottom layer. And now I can add it this way. Right, these are LEDs, so it doesn't have to go on the bottom layer. Alright, and I can drag this text properly, rearrange the text, and let's see what we get. See, quickly, we have done something nice. Right? So I can edit the, see the text, it's not placed properly. So I can bring the text, I can rotate it, put them properly. Now remember, I'm still working with a grade of, the grade is not good enough. So let me set it to 0.1. I should have better control, yes. See, as I'm dragging this, it highlights the component it refers to highlights. Okay, alright, that's nice. So, good. Now, maybe I want to select all the text and then reduce the size or do something about it. I'll go to PCB filter, right? Select text all, apply to all. If I wanted a particular layer, I'll select the layer. But now I want the text on the top layer, top overlay and bottom overlay. Right, that's why I've already pre-selected it. So if I click on apply to all, you see it selects all.
Okay.
So I can't select any of the parts, but I can select the text. Okay. So I want to edit all at once. So I'll highlight it. Okay. I'll highlight it and then set the height to 0.8. Okay, if I click on Control A, it highlights everything. I'll go to properties, set the text height to 0.8. See, it edits everything, makes it look nice. Okay, good. So now, very nice. The board color. So, most PCBs are this color, but you see that sometimes for just visualization of computer, I don't like this color. You can change it as well. You go to view configuration. Okay, view, right? And then view options, configuration, standard 2D, right? You see, I can now select. You see, if I press 2, it comes here. 3, it goes there. If I go here, I go to configuration, I can select Altium 3D black. You see, the board color becomes black, blue, 3D white, 3D blue, a lot, green, light green. So let's keep it at what should we keep it? White. It's fine. All right. So the next thing is to now route it. Routing. Okay. So I'll save it. Now there's something called DRC. You want to make sure that as you are routing, you don't do any errors. All right. So you go to routes or design rules. All right. So much rules. Clearance. Let's talk about design rules. After you have done your routing, you inspect everything to make sure that everything is fine. But you don't do it yourself. You let the computer do it for you, and it's done using the rules. So clearance. What is the minimum clearance between maybe this and that? Okay, or what is the minimum clearance between a path like this? Maybe just look at this. I'm routing from here to here. You see, how close should this get to that? Okay, because if it gets too close, it will contact it to be a short circuit. Okay, so you have to set all those things. So I'll go to design rules, minimum clearance. I can set it to advanced and it will map so many things, but I'll just set it to minimum. All right. And I can set between a track and track 0.25 millimeters. I can set so many things there. Should you allow short circuits? If you click on this, it means it will allow short circuit and your circuit won't work. Okay, unrouted net. Should it check that a net hasn't been properly connected? Yes. Right. Good. Width, routing width, you can leave it like that. Just leave it like that. When you grow older in this program, you will learn how to use it. So just polygon collect, every other thing, just leave it like that and click on OK. Okay, so what we want to do is now route it. So I'll still click on save. Now in the routing, I'll see interactive route connections. I'll click on that. Okay, there is a way to automatically do it. I can go to route, auto route, or okay, I'll select default to there. I'll select the method default to the layer board and route all, and then it will auto route it for me. See, it has finished routing. But usually I don't like to auto route because it doesn't do it nicely enough the way I want it. If you have set it properly, it can do it. But I don't like to do that. So let's go to manual routing. I'll click on this or on that. Is the same thing. Right. Now I want to connect the 5 volts. 5 volts. Now remember, I can click on shift spacebar. Usually I want this. Okay, I can change the width. Let me set it to 0.5. The size change 0.5. Okay, why is it not? You see, it's not minding me because look, the trace width is out of range for the current tool and will be clipped. Good. Why? Because of the design rules. Let's go to width. Okay, the width. You see, I said that the maximum should be 0.25. That's why it's not allowing me. So let me set the maximum to 10. Okay, that's all I want to do now. Okay, now I usually like to route it and make the decisions as I'm routing. So let me set it to 1. See, it's becoming bigger. Okay. Now I'm on the bottom layer, so it can never get on top. Let's learn. So to route on a particular layer. Alright, maybe this one is on the top layer, that's why it's red. The blue ones are on the bottom layer. So I'll click on top. It means that I want to route on the top. So I'll click here. Okay. Do you get what I mean? Good. Now it's the same 5 volts. So I can tap it from here. Do you get what I mean? Okay. It's the same 5 volts from here. So I can tap this from here. I can drag it the way I want it. You will learn. Alright, now what about ground? Now remember, this is this is ground.
Yes, sir.
I can't pass it, you see,
Yes, sir.
but I can, if I can't pass through the back two. Okay, so let me go to the bottom layer and I can now come. But I'm on the bottom layer, so how do I come on the top layer? I can press the plus key. I need to put something called a via. It's like a pipe.
Okay.
This is a pipe so that I can move through the pipe and come to the top layer. Alright. And then can you see it?
Yes, sir.
Okay. Now I can connect that. This is called a via. Okay. Good. Now I can connect this again to that. Okay. Now I need to connect this to that. Remember, if I come from here, I'll hit.
Yes, sir.
So what can I do? I'll place a via. Go under it. But if I come here, I can still go. I can go around it this way, but it's going to be a lot of work. Alright, so I can place another via. Alright, and then you get that.
Yes, sir.
The last, not the last. Now I'm still in the bottom layer, and now it's in the top. And then I can connect this. Okay, I need to connect this to ground. Connect this to ground. It's fun to do it. You can spend several hours doing it. And this is in the bottom layer. Okay, and this is 5 volts. Okay, so I have to go to the bottom layer. Then go here. Okay, these are all connected to the same, and this should be connected together because they are all ground.
Yes, sir.
Okay, now I need to connect this to that, so I'll go through a via. Alright, come to the top and connect it. I need to connect this to that. But again, I've done all the connections. Alright,
Yes, sir.
yeah. So to know whether you have done all the connections, go to design rule, run design rule check, and see number of unrouted net constraints. That means that whether you have to let some nets unrouted. You also want to check that short circuit is 0, unrouted net is 0. These are the most important, and net antenna is also 0. Alright, now I don't have any problems. It's fine, everything is fine. I have my first PCB. Okay, very, very nice. Any questions? So I'm going to